Hello and welcome to the first episode of Time to Code. Today we're going to be looking over one of my pieces here, which is the Go helper, and then we're going to be moving into some basic C# and TCP connections and explaining how that all works. So here we have a basic class namespace. We have our using here, which these reference our DLLs and our references. So here we've got a system. The system.link is going to live inside of that. System.text as well. System.threading most likely as well. And then the system.collections lives in there. So that's all of our data that we need for this particular class that we have here, which is our console writer. You can see it up here. So we're in the Go helper namespace. We have a summary here of the class, which is just a cleaner way to timestamp and color console output. So we have the public class. The reason I started with C# for our first episode is because it gets the idea of object-oriented and object orientation. So when we move into HTML and we have a looser DOM or document object model, it makes more sense. So here we have our class, which every class needs to be either, if you leave it non-public and you try to pass it around, it's going to scream about it being less accessible than itself. So we have a public class. This particular one is static, doesn't necessarily have to be. And then we declare our class and we name it, in this case console writer. So now we're going to move down to our write line, which again we have a summary, writes a line automatically and breaks to the next line. Some information about our parameters inside of it, which we can see here: message, timestamp, foreground, background. So, and then some definitions about that. I'm not going to get into all that right now. Basically, all this does is it sets our foreground color here, sets our background color, it checks if the timestamp, adds the timestamp if it's there, writes the message, and then resets our colors. The write is very similar. Only difference is that instead of breaking to the next line, it does not automatically break, but we can have it return to the beginning of the line if we want to automatically here using this bool. And then the other one is just a blank. It just prints a blank line. So let's go ahead and close that and look at our base64 class here. Again, we have our namespace, Go helper, and all of our usings. Brief summary about our class, which is called base64. Again, it's public and static. We have a function here called encode. It takes a string and it outputs a string. This right here, right before a function. So inside of a class, you'll see public, private. There's a couple other variables that can show up there, but typically it'll be public or private. Sometimes you'll see, I think, local. Sometimes you'll see static here. It doesn't necessarily have to be there. There's other things that can show up there, like async, depending on the task, which we're actually going to talk about a little bit today in our TCP queries. So then we have what we're going to output. So if it's going to output nothing, it would be void. Otherwise, like an integer would be int, a string in this case is string, and so on and so forth. The name of our function, and then our parameters for the function. So this one takes a string of plain text. And in this case, we're just encoding base64, which is a pretty standard encoding for web and PHP, but it's not intrinsically available in C#, so I just made this to make it easy for us. Then we have the decode for it, which again, it just takes a base64 encoded value and outputs a plain text string. Just saves me a couple lines here. As you see, it's only 2 lines, but it saves me a couple lines. Alright, so that's the idea behind the Go helper, in case I use that. So let's go ahead and get right into this. I'm going to go ahead and save whatever changes I've made to that. So we're going to start with the server here. So whenever you start, this is a console application. So I'll go ahead and actually show you guys this. We're just going to write the line test, right? And it's going to automatically die. And the reason that is because when a console application runs, it runs until it doesn't have anything to run anymore, and then it just closes itself, right? So I could actually go into a command prompt and kick it over, and it would show me this test, and then that it just dies, right? But instead, to get around that, what a lot of people will do is while true. For doing that, it'll now just continuously run in that loop forever, right? So we see our test, and it's timestamped there. Okay, so we're going to close that. And personally, I'm not a big fan of the while true. The reason for this is because it's not controllable. You can't change true. True is always true, right? So what I like to do is go private static bool running equals true. And what this allows us to do is say while running, we're going to keep going. And then later on we can change this running flag to something else. We can change it to false and actually kill the application instead of, you know, basically quitting in the middle of this loop. Okay. So the next thing we're going to want to do is move out of statics. So we're going to do a public void. We don't want it to return anything, and we're just going to call it start. Right? And then we're going to create a new program, which this is our main class up here, right? Program. And we're going to do start right off the bat. Okay? So we're just going to run new program start. And we actually need to run it above our while loop, because like if I could take this, this is single threaded, static like this, single thread. There's no async happening here, and we're in a while loop. So if I run this, we'll get our test, but now we're stuck in this while loop, and it'll never come out of it until we tell it that it's not running, right? So this never gets ran. So you need to take this up here and put it right there. Okay, so now that's going to run. Now, one of the issues that we're going to run into here is if I say, for instance, if I said while running, console writer, write line, running. Okay, and then we're going to put a task delay in here of 1 second. Alright, now I'm going to put a while loop in here. This is while true. Sorry about that. I had some kind of minor network bump. That was odd. Okay. So anyways, if we put while true in here, now we're expecting this to put running every second, right? While this is running. Start this. What it's going to do is it's going to say test, right? And then it's going to run this program. Now it's going to expect this program to end before it continues into the while running, right? So this has got a while true in it, which is never going to end, so we're never going to see running. So the way you get around that in C# is you use threading or tasks. So we're going to say, instead of new program, we're going to say new task, and then inside of that task we're going to create the new program, and we're going to tell that task to start. So now basically what we're doing here is we're creating a new task, which is similar to a thread, but more intelligent about how it manages its resources. It won't create thread locks. And then we're going to start it, right? And then inside that task, it's a lot like a function. So we're just going to tell it, you know, to start the program. Okay? So now what we'll see is even though we have this true here, and we're going to be stuck inside this loop, it's going to be stuck inside of its own task. So we see that running, right, every second. And it's not taking the task delay. That's intrinsic. Basically, I'd have to make this an async for it to take it. We don't want to do that anyways. What we do want to do is we want to make this an async. So So we're going to make public async void start, right? And we don't want to do true. Okay, so there's some information we're going to need when we go to start this thing. We're going to need to know what IP we're going to start on and what port we're going to start on, right? So what we're going to do is we're just going to assume every IP address. So first thing we're going to need to do is add all of the classes that we need, right? So using system.net and using system.net.sockets. Okay, those are the two that we're going to need for a TCP server or a TCP client, either one. And then we're going to say IP address host equals IP address any. So that's any address that's attached to this computer. It's basically going to put 0.0.0.0, anything that's available. And then we don't know what port we want to use, right? So we need to ask the user what port they want to use. So we're going to say console.write enter port. We don't want to timestamp it, and I don't want to color it. So that's good enough right there. Okay, and then we're going to take the variable that is the port, which is going to be, and we're going to make it equal to an integer parsing of whatever comes through the console. So console.readLine and whatever gets through there. Okay, so what we're also going to, actually, you know, one thing that we're going to try on this, or we're going to do on this instead, is what we can do is say integer port equals, and we can make it default, so let's say 664, 6664. Okay, and then we're going to say integer try parse instead of just straight up parse. Okay, try parse. And we're going to say out to port. Okay, so that's going to try to parse whatever the read line is out to the port. If it can't, then it won't output anything at all. And we'll just default to 664 or 6664. Okay, so another thing we could actually do is, instead of this, we could do a try catch if we wanted to alert them that we're going to be defaulting to another port. I can actually show you what that looks like right here. So we could say so that's what that'd look like, and then we'd have a catch. That's an exception catch. Port equals. And then we'd say like console write line invalid port plus, and then we drop the message, whatever the error message is, and then also tell them using default port 6664. And actually we could just go like this so we know it's always consistent, right? We do want to drop a timestamp on that, and I actually want to color this red. Okay, and then I do want to drop a, actually I don't want to drop a timestamp on that, and I do want to color it yellow. Okay, perfect. So we're going to drop our test here. We're just going to say welcome, and we don't want a timestamp, and we're going to make a console color magenta. Perfect. So then we can say on here, actually we could say console writer write line received port. Alright, so let's go ahead and test that really fast. So we're going to enter a port 995, receive port 995. Perfect. So now we need to go ahead and start up our listener, which we want to make that accessible from all over the class, right? So we're going to say private TCP listener server or listener, and we're just going to leave it at that. And actually I'm going to create a null on it. And then right after we collect our port, we can tell the listener to be a new listener. And then tell the listener, oops. And yeah, this is where we're gonna put our endpoint. Now it tells you port right there, but if you try to do that, it's gonna tell you it's deprecated, so don't do that. You're gonna want to use an endpoint. So we're gonna do a new IP endpoint. And again, it's going to be address is going to be any, so we're going to use our host here and then a port. Okay, and then listener dot start. And what we're also going to do is we're going to wrap this in a try, just because if it errors for whatever reason, we want to know why. So we're going to say console writer fatal error message true. Oops. Messed up. And then that should be good. And then we're gonna say console writer dot write line press any key to exit, because it's fatal error. We're not going to color. And then we're going to wait for a key. So console.read key false. We don't want it printed. Or actually true. Sorry, we want to capture it. And then environment.exit. And we're going to exit with like a -1, right? Because that's an error code. All right. So otherwise, on this. If we get through that try catch without a problem, then we know that we're connected, right? So console writer TCP listener started. All right. So we have now started our TCP listener. Go ahead and make that happen. 556. It's gonna. You're always gonna get this warning. That's your firewall exception. So we're gonna allow access. TCP listener started. Perfect. So we're also gonna go ahead and color this. Make it pretty. And we're gonna color the other one as well. Color. Okay. All right, now we're ready to actually start waiting for connections, right? So we're already inside of a new task and we're asyncing, and we actually don't need to async this, my apologies. So we're inside of a new task. We can go ahead and create a new listener, essentially. That's an async task that's just gonna sit there and wait for a connection. So the way we do this is we go public async void wait for user. Okay, and we have access to the listener up here as a private object inside the class as a global variable. So we're going to tell this thing wait for user. Okay, and we're going to say TCP client incoming equals listener dot accept TCP client async, and we need to wait this. So we're going to wait for a TCP client to come in, right? As soon as it comes in, we're going to go ahead and collect an endpoint on it. Just so we know where it's coming from. And we're going to say received connection from remote address. Okay, so now typically if you're just doing a to and fro where you're going to kick up the server, you're going to wait for a single person to connect to you, deal with your connection, and then drop the server, this is fine. If you're waiting for persistent or multiple connections, where if the connection drops, you're able to reconnect, or multiple clients, then you actually need to wrap this whole thing in a while loop. And we're just going to use our running flag again here, because again we can modify it or adjust it later on to turn off the service. We're also going to check to make sure that the listener is actually should actually have a flag. I guess it's not flagging, so we don't have to worry about that. We're not going to stop the listener, so unless we have a fatal error, then we won't have a problem. Alright, so we have collected our user, and we know who they are, right? So let's go ahead and test that out real fast. So we're going to start up our application. We're going to go ahead and go with that default 6664. Okay, so we received it, and our listener started. Alright, so we're going to open up our socket. Actually, sorry, our packet sender. The little application that I use to send TCP packets. It also maintains persistent TCP for me. So we're going to go ahead and maintain persistent. We're going to say just test because it won't actually output it. Oh, got to make sure that we have the right port. Receive connection from localhost. Perfect. So now that we're receiving our connections, we need to read our connections, right? So we're going to go ahead and create a public async task that returns a string. Okay. We're going to say read stream. And it's going to take the TCP client and we're going to read the TCP client string. So obviously we output a string. So the first thing we're going to need is a string. I'm just going to set it to nothing. And then I'm going to return it so it doesn't scream at me anymore. Right? And then we also need to, we're going to go like this. We're going to go public async handle user TCP client. Okay. Okay, and I'll show you why we did that here in a minute. So let's go ahead and deal with our reading. We're going to need a byte for our buffer, which is going to be a new byte. 128 is probably more than enough in most circumstances. You can get away with like 32 in most cases, or even like 64. That's what we'll do here, save ourselves a little bit. And then we're going to use a do while loop. Now, a lot of people don't know the difference between a do while loop. A while loop is like a if loop, basically. So when it hits that while loop, it's going to check it. If it's true at the time, if any of those variables inside the while loop are true at the time, or equal out to a Boolean true, then it's going to run it until that's no longer the case. With a do while loop, however, it runs it, and then we're going to look at the variable. So what we're going to say is while not read.contains end of file, we're going to keep reading. Okay, so now the reason we have to do this is because at the moment read equals nothing, right? And theoretically, what you could do is go read buff and string read. Okay, and then we could go and actually that's not the way you'd want to do this. The way you'd want to do that is go read bytes equals 0. Okay, and then we want to go and not read bytes equals 0. And what that allows it to do oops, set it as a string. It needs to be an integer. So what that allows us to do is while we're reading the stream, we can actually count how many bytes came through. And if we receive no bytes in one of the things, we can assume that we're done. So what we're going to do is say we need to collect our stream first. So now that we have all our stuff there, we need our network stream. You can just get it from the client. Okay, and then we're gonna go red bytes equals stream await stream dot read async. We're gonna put it into our buffer. We're gonna start at the beginning, and we're gonna do the buffer length. Okay, because we're slowly gonna trim out that stream, right? So red is then gonna plus equal encoding .utf8 dot get string on the buffer. Okay, so that's it. Now we can read our stream. It's gonna know what's coming through. Okay, so there's no way at the moment, however, for it to hand off. So we've received the connection, but we haven't told it what to do with the connection. So what we're gonna do here is we're gonna say console writer dot write line handling connection. We're gonna grab that IP endpoint again. Okay, and remote.address. And then we're going to come up here. And again, because we're inside this while running loop right here, and we don't want it to stop, we want to handle the user without this running loop stopping, right? In case we have a user come in right behind them. So we're going to create a new task again. And we're going to say handle the user. Here's your user. Go ahead and start up. Okay, so now we started a new task. It can go ahead and run, and the while running loop can run back to the top and wait for the next client to come in. So we're going to say handle user while client is connected. We are going to wait for a read in this case. So we're going to say read string read equals await read stream on the client. Okay, and then as soon as we get that stream, we're going to go ahead and just write it. Received, whatever received. Okay. We're going to go ahead and kick that over. And what this is going to allow us to do is, again, we're going to put up our packet sender there. We can go ahead and say test. Handling connection 127.0.0.1. Send it an empty. Actually, I need to send it in a file. Okay, so what's actually happening here? I don't believe we're reading the initial value. And that's mainly because we don't have, yeah, so this is pretty much what happens when you have the bytes equals 0 and we're not catching it, right? So it can just equal 0 forever and it's just going to continuously send nothing. So what we need to do is we need to say over here, if red equals, actually we can say, yeah, if red equals string dot empty, we are going to close the client. We're going to say received blank message from okay. So now we're just going to tell it that we've received a blank connection or a blank message from them. Oops. Close that. So now what we have, I believe, is that we're not actually getting a try catch on this. So basically what this is going to try to do is read forever, right? And if the connection dies, it has no way to stop. So what we're going to do is we're going to put a try catch in here. say client's gonna close, and we're gonna say console writer, right line, client force disconnected. And then we're just going to return nothing. Okay. Get our packet sender back up here. Now it's sitting there waiting for me to either send an empty packet or send an end of file, right? So I can close that. Shouldn't still be just going through received. Let's see why it's doing that. So it's awaiting the stream read. You know, honestly, what we could do, and what I probably would do in this case, is I'd do up here. Just say if the read equals string.empty. And I think I actually just thought about what's going on here. I still like this better. So what's happening is even if it's empty, we're pushing across an empty 64 bytes. So there's slash zeros basically. So what we need to do is we need to say red equals red trim, and then red or replace an empty character with nothing, and then we're going to go ahead and trim it again just to make sure that the internal is trimmed. And then we're just going to return it in this case because we're dealing with it on the upside. So on our handle here, another thing that I want to do is put our try catch again. Since we removed it from down there, we're going to just do it over this entire async right here. And we're basically going to handle it just like we would handle a force disconnect. And then because that's not declared down there, we need to clear it up here. And we're good to go. Let's go ahead and run this. Okay. Client force disconnected. Okay, so what happened there is we got a double over. Client force disconnected, because we're still within the while loop and it's going to try to continue, right? So we need to break out of it when this happens. So if either of those things happen, we're just going to break out of it completely. Okay, so we had a client force disconnect, right? Because the read was empty on one of the reads. Okay, so now what we can say is let's see. I'll cross this for a second. Should be fine. Ah, I didn't realize I even put that in there. I don't know why I even put that in there. Must have been from my previous try catch. Okay, so now what it's waiting for is either an empty or an EOT. Or an EOF, sorry, not an EOT. Which, there it is. So, it doesn't like that. EOT, EOF. Probably, oh, we got a line break right there, so it jumped the EOF back. But I could go like this. Because it sees the EOF at the end there, it's happy with it. And that's why you have to do packet parsing. So basically the way you handle this problem is you create your own little, I don't know, micro transportation protocol. And the way I do it personally is I look for EOFs and I also look for EOTs. So an EOF signifies that they're killing the connection, and EOT signifies that they're just done transmitting, that they don't actually want to kill the connection. Okay? So we need to change this one to EOT. And then we can handle the packet individually, right? So we're going to go outside of this class real quick. So we're at the class, the program class right here. We're going to go outside of the class and we're going to create a new one. Now this is technically an object. So we're going to call this TCP packet. Okay. And we're going to say that there's a public string called the data and a public string called the terminator. Okay. And when we read, instead of reading back a string, we're going to read back a TCP packet, which this is going to be upset about. So we're going to say TCP packet read equals null if read dot data is null. Okay. And actually in this case we're also going to say if read dot terminator equals end of file. Is the end of transmission, we're not going to kill them, but if it's the end of file, then they're forced into disconnecting themselves. Okay, so we're going to return, we're going to create a new TCP packet. So TCP packet return packet equals a new TCP packet. We're going to say the return packet dot data equals whatever we read. Okay, now we need to split this out and clean it all up, right? So how do we figure out what the terminator is? Well, we know for a fact that it's either EOF or EOT, right? So first thing we need to check is if the read length is equal to 0. So did we read nothing? Because if so, then we're just going to retain a new TCP packet. There's no point in even trying to build one. If we didn't, then what we can do is it's going to be EOT or EOF with the two brackets, which both of those are 5 characters, right? So we can say return packet dot terminator equals read dot substring. We can start at the last index. We can go 5. Pretty sure that'll work. And we're going to go ahead and just dump this. Just make sure I'm right here. Okay, so we're going to go ahead and run this really fast. What did I do? Oh. Needs to return. Okay. Force disconnect for some reason. Keeps force disconnecting me. Wonder why that is. Okay, so client force disconnected. Maybe because it's reading the data as empty. Or it's getting an error from this. let's go ahead and say let's go and log this exception just so we know what's going on. Oh, derp derp. Okay, so it's like this. Pretty sure. I knew there was a way to do that. Hold on, check really fast. Ah, that's what it is. Ah, that's right. So we just have to go read that length, -5, and then we're gonna grab the 5. Oops, that's not what I wanted. Substring. Okay, so that should do us. EOT. Okay, so now we're getting it. Now it's bitchy again. Alright, so we're actually going to do this a little bit differently. We're going to do red dot data that length equals 0. It's a little bit more dependable, in my opinion. Okay, so what it's screaming about here is that these aren't set as anything. So you need to set them to something default. Now I can close that and it'll see the force disconnect. Okay. Alright, so we're halfway there. So now we can read the data, which we also on this side want to do dot replace any EOTs with nothing, and we also want to replace any EOFs with nothing. Kick that over. So we should receive test. Perfect. We're going to go ahead and make sure that we're not writing out our terminator there. And we're looking pretty good. So obviously there's a lot of other things you could do with this. If you wanted to do, you know, JSON in the packet itself, you could actually do like public TCP packet, whatever you read, and then you could take this piece right here and drop it in here if you plan on using it multiple times or moving packets around a lot, and then just say like that. Or actually, just give this nothing. And give this red. And then say that, give it to itself. And there you go. That'll create itself basically. Another thing you can do is say if red equals length equals 0, and we're just going to return and do nothing. Okay, so that looks pretty good. Let's go ahead and look at getting a client in here. So let's start this one more time. We'll use our test client here to send some stuff over. So test, test2, test3, and let's end our file. Okay. So one other thing that I want to do with this is I actually want to parse this out. Oops, stop that. I want to parse this out, and I want to make this a separate if statement. And actually I want to tie it into this one. And the reason I want to do that is because we want to write before we say the self-disconnected. Okay. Alright, so now let's just try this one more time. Make sure that we can send a test. Send another test. And then send a third test and kill ourselves. So client self-disconnected, test 3. So, okay, and the reason that that's doing that is because we need to go client.close and then return, or break. Okay. So that's looking pretty good. We should be able to... Now, one of the things this isn't covering at the moment is timeouts. So we can send this end of transmission right here, and you can see we're still alive. You can see the timer counting there. It's not going to kill us. It'll sit here and live forever until we kill it from one side or the other. So we can kill it on this side, or we can kill it on that side. One side or the other has to disconnect before that connection, or force each other, the other person to disconnect before that'll end. Now, there's the best way to handle that is to just handle it read time. So you can set timeouts for the client itself when they come in. So when we handle the user, right here we can say incoming dot timeout equals 2, incoming dot timeout equals 2. But realistically, that I found that not to be reliable. It's not dependable. So what I typically do on top of that is I will, as soon as we go into a read right here, and we're awaiting the read async, I'll say I'll create a date time. It's called started, and it's equals now, and then I'll do a I'll say date time dot started. Oops, started equals, damn it, date time dot now. As soon as we start reading again, and then I'll do down here. I'll do and started. Less than 2 seconds. Okay. So we're gonna wait for less than a total of 2 seconds for it to all go down. Which should mean see, I've had this issue before, and the only way that I actually found to solve it was to put a stop on the task itself, which basically what that means is yeah, so basically the way we do that is instead of doing this, that's one way to do it if you were in a synchronous, but we're not, we're in asynchronous here, so that won't work. But what we can do is we only wait for the application for 2 seconds, or for the task to finish for 2 seconds. So for task, actually, so the best way I can think of actually handling this is make this a task, create our packet, and then just return the task completed. And then what we can do up here is right next to our listener, we can say private TCP packet received, and just call that null. And then what we'll do is we'll say var received. Okay. And then actually no, we don't even have to use red at this point. I'll fix that in a minute. But what we want to do here is we want to go received equals return packet, or received equals a new TCP packet with nothing in it. Okay, so now we're able to grab our received, and it's all there. So now we should have a timeout. Thing's only going to wait for 2 seconds. Apparently it continues receiving. And the reason it continues receiving is because when we handle it, we need to temp it out. So basically we need to say, doing it the way we were doing it actually wasn't bad. So we go TCP packet red equals null, and then red equals received, and then received equals null. What that allows us to do is check, we're resetting it basically. We weren't resetting it last time, and so it was just continuously pulling the same information over and over and over again. Oh, and then we need to set all of our receives back to reds. connection. Didn't see the EOT this time though. That's interesting. Wonder if, yeah. I missed one. Receive test, and then we shit all over the place. Okay, so what we need to do is say, well, that actually should come through without a problem. And we'll just do new, so that way it'll be empty. It won't be a null packet, it'll just be an empty packet. Actually, what I want to do as well, since we're doing it that way, when we initially start it, I want to set it to an empty packet. Might be able to add, I want to try to do it at runtime though. Alright, so client force disconnected because we didn't respond in time. So we're going to take a couple of these with us. Almost can't respond fast enough. So we're looking pretty good there. Let's go ahead and we can start creating a client. So let's kick over our client here. It's basically going to be the similar process. We're going to start off by creating a bool. We're going to set it to running. Create a, in this case, we're going to create a TCP listener though. So we're going to have a TCP listener, or client, sorry. I'll put the client equal to a new TCP client. And then we're going to go ahead and connect to ourselves. So first thing we're going to want to do is to do a try catch just in case. Then we'll know why, and we can go. I'll put this all into one function eventually. Okay, so we're going to try to connect, and we're going to try to, first we're going to say var, let's see, let's give them a little options here. and then we're going to go client.open or connect to our new IP endpoint of address and port. Alright, if that works out and we don't go sideways on that, then okay, so what we're going to do now is I'm going to go ahead and kick up the server as its own application. Get it kicking over here. Alright, and then we're going to go ahead and kick off our client example. So it did a handle connection, and it did receive the connection. Obviously it force disconnected it because it didn't say anything. So we're going to go ahead and close that out. Close that out. Looking pretty good here. So I'm actually going to go ahead and take a step back for a minute. I will be right back. Go clean up my brain a little. Alright, so it's a little late and I'm being a little silly. I'm gonna fix a couple of the issues that I did that I was just thinking about being silly. And then I'm probably gonna head to bed. Pick this back up sometime tomorrow. So what I did is when we're handling our user, I told it to read the stream right here, right? And if we received it, yada yada. And then we're resetting the packet to like nothing. Um, we can reset it to null here, and we don't need to primary set it here because when we're doing this task run, we should be checking if task is equal to false, then we should be closing the client, letting us know that the client timed out, and then breaking out of the while loop. Basically what that'll allow us to do is actually track when a user times out. See? And we won't get that issue about being able to set our stuff to null. So that fixes this round. I'm gonna go make a couple fixes in Go Helper, and then I'm gonna head to bed. So thank you anybody that dropped by tonight or anybody that watches this in the future, and have a wonderful evening.